All right, we're going to go ahead and use the limit laws and the graph to evaluate. So if I look at A, it says the limit as x approaches -2 of f of x plus 5g of x. So what I'm going to do is use my limit laws to break this down. So the first thing is, as x approaches -2, I see addition, so I can actually find the limit of each one through addition. And then the other thing I would see on here is, you guys see how that 5 is a constant? So I would go ahead and move that out in front. So I have the limit as x approaches -2 of f of x plus the limit as x approaches -2 times, sorry, I can bring the 5 in front, 5g of x. And now that I've broken it down using my laws, I can go ahead and find each limit. The biggest thing you guys do, we need to check from the left and the right, okay? So from the left and the right as x approaches -2 of f of x. So I would go where x is -2, which is here, and then I would go up to function f. Okay, looking here, if I look at it from the, sorry, I'm not at -2, am I? Here's my bar. Okay, -2 is here. If I go up to function f, remember limits always follow the curves. And as it approaches it from the left and the right, okay, I got to confirm that it happens from both sides, we get a value of 1. So this is 1 plus 5 is our constant. And now we're going to find the limit as x approaches -2 from g of x. So let me just make sure I'm counting right again. Here's -2. Go down to function g. From the left and the right, my y value is -1. So I would have for part A, it'd be 1 minus 5, which gives me an answer of -4. So there is A. B, we're going to go ahead and look at, I'm going to pull it down here, the limit as x approaches 1. I can break this one apart. They're being multiplied, so I can find the limit as x approaches 1 of f of x times the limit as x approaches 1 of g of x. Okay, so if I go to my graph, I would look at function f first from the left. Sorry, here's 1. Going up to function f from the left and the right, they are matching up to be the same number, so that's good. So my y value is 1, 2. So this would be 2 times my g of x value at 1. So if I go to g of x, at 1, my curves are leading me to 2 different answers. So I might actually break this one down and check it from the left and the right. Okay, my f of x function is the same from the left and the right. Let's just do this one from the left first. So if I approach this g of x from the left, if I use that value, that would give me -2, which gives me an answer of -4. Now if I evaluate it from the right, okay, my f of x is the same because it's the same from both left and the right. My g of x from the right-hand side, that's coming from this direction, is giving me an answer of -1. So this gives me -2. So do my left and my right-hand limits match up? They do not, okay? And so since my left and my right-hand limits don't match up, my overall limit does not exist. So this one for B is it does not exist. Okay. And then lastly, we have C. Let's just go ahead. I'm going to write that one up here. We can, with division, break it apart. So I have limit as x approaches 2 of f of x all over my limit as x approaches 2 of g of x. So my limit as we approach x equals 2 for f of x. So I got, here's 2, here's function f. Make sure it's the same from the left and the right. It is. It looks like about 1.5. And then I would do g of x. So as we approach 2. And this one is the same from the left and the right. And it's approaching my y value of 0. So I have 1.5 divided by 0. However, our limit laws state that our denominator can't be 0 because you can't divide by 0. So this one, since we cannot divide by 0, we usually say it's undefined, but with limits, it does not exist. DNE does not exist. So there are our limit laws being used with an example.